Hello everyone. So today we are gonna create singly linked list using Python. Okay. So this is my program, and as you all can see that we have a class node, class singly list containing different methods such as append, prepend, add before, add after, and remove, and we have traverse. This traverse function is going to print or display all the contents of our linked list. Okay, so let's run this first and see that how is it going to work. uh, we just uncomment this. Okay, so let's just run it and see what's our output. It says list size is 0. Okay, as we have not uh, included any new data, and now we are going to uncomment append. Okay, so now we have appended 1, 2 and 3, and let's print it and the size. We have 1, 2, 3. Initially the size was 0, and now we have 3 nodes. Okay, now we have to prepend. Okay, so we are now 0 minus 1. We are now running our code. Okay, minus 1 and 0 has been prepended. As you can see, minus 1 is the first item in our list, and we have to add zero point 0.5 after 0. Okay, so let's add after 0. We are adding 0.5. Add before 0 minus 0.5, and we are removing 0, and as you all can see that 0 has been removed, and there are 1 2 3 4 5 6 7 8 items. Okay, so it's working fine. Now let's create it. So we'll start from class node, defining our init method, and it says data self dot data equals to data, and self dot next equals to initially set to none. So this next is a variable which is going to point towards the next node. Okay, so that's how singly linked lists work. Now we are going to create our class singly list init method, and initially we will have self dot double underscore head. I'm putting double underscore to make it strongly private in Python programming language. Okay, so we have this way of making a variable weakly private or strongly private. So if you wanted to make it weakly private variable, you can just put single underscore, but I want to make it strongly private, so it's set to none. And we can make a tail node also set to none. This head node points towards the first node of our list, tail node points towards the last node, and we are going to make this third third variable known as size, initially set to 0. So this size is going to tell us the number of nodes in our data structure. Okay. Now we are going to make our first function append, and we are going to append some data. Okay. What is this append? As you all know that append means to add a new data at the end of our sequence. Okay. So first we create a new node variable, and it initializes our class node, and we pass this data which we as a user want to add. Okay. Now first we will check if the list contains any data or not. So if self dot underscore size equals to 0 and not self dot head, and I just want to include all these things just to make sure. You can just use size variable only, it's upon you, and not self dot tail. So this line will check whether the size of our list is 0 and there is no head or there is no tail. Okay. So when all these three conditions are true, we are going to initialize or set head node towards new node. We are going to set the tail node towards the same new node. So we have this head node and tail node which points towards the same variable. Okay. And now we have to increment the size by 1. So our list contains one set of data. Now else, if there is one or more than one data in our linked list, then we will be doing something like this. We have to self dot tail equals dot next equals to new node, and we will now point self dot tail towards new node. It means new node is the new tail node of the list. I hope I am clear to you all. What we have done so far is we have first checked if the list contains 0 data, then we have initialized self.head to new node and self.tail to new node, and self.size has been incremented to 1 by 1. Sorry. Else, if there exists one node or more than one node, we are adding this self.tail.next variable, and it is referring towards new node, and self.tail is now referring towards new node. Okay. Finally, self.size plus equals to 1, and we are going to delete this line because we don't need it. Okay. Similarly, we are going to make prepend method data. We are going to copy these lines because these are going to be the same. Okay. So if there is no data, it is going to set head and tail nodes towards new node. But if there is any data, now what we have to do is new node dot next is set to self dot head. We are prepending our new data, which means we have to add this new node just before our head node. So new node dot next is going to point towards our head node, and now self dot head is set to new node. Finally, self dot size is incremented to 1. Now let's just make this traverse function, and this method prints all the data in our list. So current node is set to self dot head, while the current node is not none, because we know that the last node always points towards none. Okay, so while current node is not none, print current node dot data, and we are now updating this variable current node, and it is going to refer towards the next node. Okay, so let's check this. If name I'm creating or instantiating or creating an object of our singly list class. Okay, so now we forgot to make this function, define this function, which says list size. It's going to return self dot size. So print size my list dot list size. So let's just run it. Okay, so initially our size is 0 because our list doesn't contain any node. Now we are going to append some data. Okay, so we are appending 1, we are appending 2, and let's check it. Oh, it's not showing anything. What happened? Oh yeah, my bad. We have to use this mylist.traverse. Now it's going to show all the data. See, 1, 2 has been appended, and our current size of the list is 2. Okay, now we are going to prepend our data. my list dot prepend, let's prepend 0, and let's prepend, oh sorry, prepend -1. -1 and 0 has been added to to our list, and our list size is 4. Nice. Now let's make two more methods which are going to be add before key value. This key will represent the value which we want our data to be added before. Okay, so we are going to add this data before key. I hope you get me. Before the node which contains our key. Okay, now first we have to check if the list is empty. If self dot size equals to 0 and not self dot head, let's open this. We are going to print add some data to the list, else. Now we are going to add before, right? Current node is equal to self dot head. Okay, so previous node is set to none, while current node, if current node dot data equals to key, if we are successfully finding our target node, then for now we just pass it, else previous node equals to current node equals to current node dot next. So we are storing the value of current node into this previous node variable, and our current node now points towards the next node, right? Now if not previous node, now it means that our target node is the our target node is the head node, right? So this is for the head node. So now we have to add data before the head node. Okay, so for adding this new node, we just forward to make this new node variable. To add this new node before our current node, or let's say our head node, we are going to do something like this. New node dot next equals to current node, and self dot head will point towards new node. Else, if it's not the target node, then we are going to do something like this. We have to do make our previous node variable point towards the new node, and new node is going to point towards our current node. That is how we are adding this new node before our current node. Okay, so previous node dot next equals to new node dot next equals to current node, and finally self dot size is incremented to 1, and to avoid infinite loop we are using this return statement. Okay, so let's check it. Add before, right? So we have to mylist dot add before. Let's add uh, let's add let's add 1.5 before 2. Let's see if it's if it works. Right, so 1.5 has been added before 2. Correct. Let's add something. Add before 0. We are adding minus 1.5. Oh, sorry. Let's add 0.5. We have added minus 0.5 before 0. Nice. So our add before function is working fine. Let's make another function. It's going to be define add after key data. We are going to copy these lines, this. Okay. So if there is no data, it's going to print add some data to the list, and otherwise current current node has been set to head node. New node is initialized. Previous node, I don't think we are going to be needing this previous node variable. We are not going to use it as far as I know, but let's see. If current node dot data equals to the key, else current node equals to current node dot data. Oh, sorry. Next. Now, if we have to check all the conditions that if our target node is the last node or the tail node, then we are going to add a new node after the tail node. So we are going to do something like this. If not current node dot next, then current node dot next equals to new node, and self dot tail is set to new node, else next node is equal to current node dot next. Now current node dot next equals to new node dot next equals to next node, and now self dot size plus equals to 1 return. Let's check it if it's working or not. Add after. Okay, so let's add we are adding 0.5 after 0. 0.5 has been added. Let's add 2.5 after 2. My list 2.5. 2.5 is added after 2. Let's add let's add 100 after 1.5. Sorry, minus 1. Yes, 100 has been added after 1.5. So our add before and add after function methods are working fine. Now let's move to the remove function. This method is going to remove the node which contains our required data. So first, again, if self dot size equals to 0 and not self dot head dot tail, we are going to print no data to remove. Elif self dot size equals to 1. If there is a single node in our list, then self dot head will point towards a none. Self dot tail is also going to point towards a none, and self dot size will be decremented by 1. If self dot size is greater than 1, if our list contains more than 1 nodes, then okay, so current node is going to be self dot head. Okay. While current node, if current node dot data equals to data, then temporarily passing this, else current node equals current node dot next. So the current node is updated and it refers to the next node if we don't find our data. Now we have to check various conditions. Condition 1 is going to be if removing the head node. When we have to remove the head node, we are going to check. Oh yes, we forgot to do this. Previous node is set to none, and in here previous node is equals to current node. If not, previous node. If the previous node is none, then next node equals to current node dot next, and current node dot next is none, delete the current node, and self dot head will now point towards the next node. Elif not current node dot next. If there is no next node for our current node, it means that we have to remove the last node, the tail node. So removing the tail node. So previous node dot next will now point towards none. We are deleting our current node, and self dot tail will now point towards our previous node. Else now arbitrary node, but not the head and tail nodes. Okay. So previous node will now, okay, we have to do this. Next current node dot next. Previous node is going to point towards the next node. Current node dot next equals to none, delete current node, self dot size equals to 1, and return. Okay. You can return true or false, but it doesn't make any difference. So now let's look at what we have done so far. First, the function or method checks if there is any data in our list. So if the size is 0 and there are no head and tail nodes, then we are going to print no data to remove. If the size of the list is 1, then we are going to point the head as well as tail nodes towards a none and decrement the size of our list by 1. Now, if our size is greater than 1, it means that we have more than one nodes in our list. Then the current node is set to the head node and previous node is none initially, while current node. It means while the current node is true, or we can say while the current node is not none. The loop will terminate when the current node becomes a none. Okay. So if the current node dot data is equals to data, it means we have successfully found the target node to be removed. Now we have to check various conditions like removing the head node, removing the tail node, and removing any arbitrary node, but not the head and tail nodes, because obviously we have checked two conditions before this else part. Okay, so if there is no previous node, like if the previous node is a none, so next node is going to be current node dot next. Current node dot next is set to be none, and we have deleted our node. Now for the tail node, we are now setting the previous node dot next to none, and we are deleting this current node. Python would have deleted this node anyways because life cycle of any object. Just to make it clear, Python would have deleted this node anyways because of the life cycle of any object. What do I mean by this? It means that if no variable is pointing towards a particular object, everything in Python is an object. So Python will automatically delete this node or that object which is not referred by any other variable. Okay, so let's check this. My list dot remove. We want to remove 0. First remove 0 and run the code. Okay, so 0 has been removed and there are 1, 2, 3, 4, 5, 6, 7, 8 nodes, and it's showing the correct number of nodes. 0 has been removed. Let's remove -1. List dot remove -1. Okay, -1 has been removed. Let's remove 2.5. My list dot remove 2.5. Okay, 2.5 has been removed. So this is our basic functioning of a singly linked list. And yes, I want to tell you guys that we could have made this code without using the tail node, but I decided to make this tail node so that while removing or adding a new data to our list, we can directly or we can append a new data with the time complexity of order of n, sorry, order of 1. So if you have studied time complexities in computer science, I expect that you know about the various time complexities like constant time complexity or n order n time complexity. So here, if we are appending directly towards to the tail node, we are doing this in order of 1, constant time complexity. Otherwise, we would have to just make a while loop, and we will have to traverse through all the nodes in our list, and we will have to then append or remove the data, the new data, or whatever you want to do, and it's gonna take order of n, and we don't want that. So that is why I have included the tail node in our code. So this is our code. Thank you very much.